Alright, so let's move into problem number 28 now. So this problem talks about some spiral. Okay, so in this spiral, it starts with number 1 and then we move right and then down in the clockwise cycle, just like that. So you see 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you have completed the cycle, then move right 10, then 11, 12, 13, 14, 15, so on. So this is the example of 5 by 5 diagonals. Here you might see the 5 by 5 has 25 elements. So that's why it started with 1 and it finished with 25. 25 with the top right corner. And in the center value is 1. Now the first, it starts with 1 and then the size becomes 3, then size becomes 5. Next size will be 7. And so on. So it will be, the size will be odd. Size, in this case, size will not be even. Size will be odd. And the question says, if you really calculate the diagonal values of it, sum all the diagonals value, then this will be 101. Here you have to see one thing, 1 is common for both the diagonals. So you'll have to count 1 only once, not twice. And the question is asking, in similar manner, if we create a spiral of 1001 by 1001 matrix, so there will be matrix of 1001 by 1001 in this case, and what will be the diagonal, sum of the diagonals for that 1000 by 1000 matrix. So that's what the question is asking. So therefore, in order to solve this problem, first we'll have to see, let's say I have 5 by 5 already. Now let's say I want to create the matrix of 7 by 7. You'll have to see what already you have. So it will be something like that. This one will be 26, then 27, 28, 29, 30, 31, and just like that. Basically, you will have to create the outer shell of this matrix. The inner shell is already there, which in other way, which means if you want to create a matrix of n by n, you already have something with this one, which is of size n minus 2, because 1, it's incrementing by 2. That means you would already have the matrix of size n minus 2 and you'll have to create just the outer shell so that you can create the matrix of n. So I think you guessed it. So what I'm trying to do is I'm trying to create a recursive call where I know from n, when I'm trying to create the matrix of n, I will just reuse the spiral of n minus 2 which will be a recursive call. And when the size is equal to 1, then we return just the ones. So let's see how we can code this problem. Okay, so I'll use numpy here because it's easy and it's faster. Import numpy as np, and so let's define the function. So define get spiral matrix. Now here we'll have to see if n equal to 1, then we'll return 1. That will be 1 with size 1 by 1. Okay, so we'll just say np.ones and then size 1 by 1. So n is equal to 1 is already known. Now let's say our final matrix will be np.ones. I'll just initialize with 1s, but we can initialize with 0 as well, it doesn't matter. N by n. So our ultimate matrix size will be n by n. That's why I just created an empty matrix with filling up all the values of 1. Now here we'll have to see one thing. So in our matrix, let's say this is 5 by 5 and 3 by 3 is already there. And what is this 3 by 3? This is the position for 1. This is position number 0. This is position number 1. And this will be position number n. This will be position number, no, sorry, this is position, if this is position number n minus 1. So this is n minus 1, 0, n minus 1, and this will be n minus 2. Okay, so what do I mean by this? So let's assign this. That means matrix of 1, 2, n minus 1, then only it will go up to n minus 2. Then 1, 2, n minus 1 again. And this value will get it with the recursive call. Get spiral matrix, size n minus 2. Okay, so this one will be assigned. So that means our inner shell is done. Now we'll have to figure out our outer shell. Okay, so the first one, matrix 1 to n minus 1. That means the first outer shell is this one, this part, which we are trying to create. And the row position will be 1 to n minus 1. And the column position is fixed, that is n minus 1, because this is the right column. And the values should be actually the n square. If you look at that, it will be n minus 2 square. For example, this is 5. So this is 5 minus 2, 3 square plus 1. So we'll start with n minus 2 square plus 1. That will be our first number. So it will be like this: n minus 2 square plus 1. Okay, that's our first number. And second number will be comma, that will be n minus 2 in bracket n minus 2 square plus n. Let's see if that's working. N minus 1 plus n. So basically here this one is n minus 1 square, that means 9 plus n. 9 plus 4 is 13, but we'll have to go until our range will be 9 plus n 14, 9 plus 5, then only we'll get 13. Okay, so just like that, because we are trying to create a range here. I'll just show you what this range is giving us, and then we'll have to convert this into a list because we are assigning it. Okay, so let's have a look at it. Let's see this value. Let's see what this value is giving. Let's say our n is equal to 5. So we got 10, 11, 12, 13. If you look at here, we got 10, 11, 12, 13. That's exactly we are looking for. So that's our first right hand side cell is complete, or the column is complete. Next we'll just do the bottom row. And what is that? That value is this again, matrix 1 to n, because that's this will be the row position is same because it's n minus 1. Then the column position is 0 to n minus 1, and the values will be, in this case, actually it will be from this plus 2n. This should be our starting point here, and that will be n minus 2 square plus 2 into n, that will be minus 2. Okay, what I'll do, instead of typing, I'll just copy. Maybe that will be easier. So I'll just take this number. So let's check this. What is this number giving? Okay, for n is equal to 5. You see, it's giving, okay, it's giving in the reverse order: 14, 15, 16, 17. And that's how I want to assign here: 17, 16, 15, 14. That's what I wanted, so that I can assign it directly. Okay, so that's our next assignment. And the next one will be the column. That will be our mat of this is going to be all the rows, the column left, extreme left column. Okay, so that will be our all the rows 0 to n minus 1 comma 0. And let's check the value. Let's try to get the value here. It is 21, 20, 19, 18. So that means it's starting with 18, 19, 20, 21. So that's the value I want to assign here. Okay, and then finally I have another assignment, that is the matrix of 0 then 1 to n is equal to, let me copy it again for typing. Okay, and let's see what is this value giving us. So this is giving us 22, 23, 24, 25. That is our last part: 22, 23, 24, 25. So let's just assign it. So once our assignment is done, I'll just return mat. Okay, now let's check if it is working properly or not. Get spiral matrix of size 5. Okay, row number 12 is having problem apparently. Okay, it's very easy to get a mistake. Instead of that, I think, let me copy paste. Yeah, so this looks to be working fine. Here just getting everything as float instead of number, integer. That should be fine. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Similarly, if I try with 7, you see the last number is 49, started with 1, like that. Okay, so you can use any number and that should work. 9, it is 81. But if you try with 8, it will fail because it has to be a odd number. Okay, so now because we have already done, now the question is asking what is the diagonal sum of the diagonal. Okay, so the first diagonal, what we can do is we can do matrix dot diagonal. Okay, let's see that I'm just assigning it to a mat. Okay, now if I just do mat dot diagonal plus mat dot diagonal, now you'll have to take the sum of it, sum of mat diagonal. Then we'll have to do np dot flip r mat dot because in our matrix, first if I ask for diagonal, this one numpy will give this, and if I just flip this matrix, that is the transpose of it, then if I ask for diagonal, then it will give me this one. So diagonal, again I'll just do sum of it. You see it's giving 102 because we have counted 1 twice. That's why you'll have to do -1. Now it's giving 101. Okay, and which is matching for the 5 by 5. The question is asking for 1000 by 1001 by 1001. So our size is 1000 of 1. Okay, and let's see the answer. Okay, so this is the answer. Copy this part. This should be our answer. Okay, let's check this out if this answer is working. Yeah, our answer is correct. Thanks for watching. Coming up next is problem number 29. And if you like my video, please share and subscribe. Thanks again.